So the first thing we have to wrap our head around is the idea of a phasor. They're going to help you calculate what's called an impedance on a circuit. But what it is it's a useful way to visualize waves. So let's say that this is our voltage. And our voltage has this normal sine wave to it. After a certain amount of time passes, this point right here can also be represented by the unit circle right there. So instead of just passing to the right here and seeing the magnitude go up and down like this, we can actually go back to the unit circle and imagine this kind of voltage almost rotating around in a circle like this. And it's useful because often voltages are not the same in different elements. And they're useful in helping you figure out basically the overall voltage. And so, one thing, another way we can use this with capacitors, remember that if you have voltage like this, capacitors are actually leading in this case. So capacitors, instead of starting down at the center, it's almost like they've got a head start back here, and they're already reaching the top here and coming down. And so these are out of phase. This is what the capacitor actually starts at. And so the idea is that while a normal voltage would be starting on the unit circle right here, the capacitor voltage, or the current, is going to be actually ahead by 1/4 period. So it means that already it started down here. And then, if you look at an inductor, in the same situation, you're going to see inductors, but they're going to be lagging. So you're going to see something like this. So while normally we would have this for like a normal circuit, the inductor starts a 1/4 period behind, and so really they're starting back here. And so we would visualize this as in a phasor diagram like this, and this should be V sub L. And so this is what you should really remember here. In the phasor diagram, a normal resistor voltage is in sync with the current. The voltage for an inductor is going to be pointing up, and the voltage of a capacitor is going to be pointing down. And now that we can, whenever we have any of these pieces, we just use these particular vectors in our problem. Now we should move on to RLC circuits.